Hello everybody and welcome to Operation Management Process Layout Design. Previously, we have discussed about types of layout, and in today's discussion, we specifically focus on process layout design. Just to remind something about the process layouts are layouts that group resources based on similar process or functions. This type of layout is seen in companies with intermittent processing system like hospitals, universities, and other service providing organizations. The challenge in process layout is to arrange resources to maximize efficiently and minimize waste of unnecessary movement from one point to the other point. If the process layout has not been designed properly, if there is a poor design of process layout, so many products will have to be moved long distance unnecessarily without any advantage. So it is a wastage. It consumes time, it consumes resource, or it is just costly without any benefit moving our resources from one point to the other point. Process layouts are very common in a hospital. A hospital is an example of process layout, and a university is another example because colleges and departments are grouped based on their functions in a university, and departments are grouped based on their function in hospitals, such as cardiology, radiology, laboratory, oncology, and pediatrics. In general, process layout groups resources based on their similar functions. Now let's move to the process layout design. By the way, before moving to the process layout design, the objective of designing a process is just to place resources closer together based on the need for proximity. There are three steps in designing a process layout. The first one is gathering information regarding space requirement or information regarding the closeness measures. The closeness can be measured by a from to matrix, or we can measure using a relationship chart. And in the second step, we have to develop a block plan or schematic of the layout. And the last step, the third step, is develop a detailed layout. Let's do an example. A Recovery First Sport Medicine Clinic is an outpatient medical facility that provides a variety of medical service to patients suffering from sport injuries. The service include exams and x-rays, physical therapy, and outpatient surgery. The total area provided is 75 times 50, which is 3,750. And the current layout, the existing layout, looks like this. A, B, C. A is radiology, B, laboratory, C, lobby and waiting area, D, examining rooms, E, surgery and recovery, F, physical therapy. So, by collecting data, by gathering information about the closeness, we will modify this layout. Or we will check whether there is an improved layout or not. So this is from to matrix for recovery first. By the way, this from to matrix for recovery first tells the frequency of movement from department to department. For example, from radiology to examining rooms, that is D, there is 45 trips, 45 frequency of movement. And from radiology to surgery and recovery, that is E, there is 12 trips. And from radiology to physical therapy, there is 25 trips. So this tells the frequency of movement from department to department. Okay, moving to the relationship chart for recovery first. The previous table tells only just the frequency of movement from one department to the other department. But this relationship chart for recovery first, as the name indicates, that it tells how the relationship, or it tells the importance of the relationship between departments, or it just reflects how much is important, how much is crucial to just put two departments together. So this table reflects the opinion of the managers with regard to the importance of having any two departments close together, based on their relationship or based on the activities what they are conducting daily. So we can decide which departments have to be put together or close together, and which department have to be far away from one another. So before discussing the closeness rating between the relationship chart, let's see the explanation of rating codes. So the rating A, E, I, O, U, X. So A means absolutely, E means especially, I means important, O means ordinary closeness, U means unimportant, and X is undesirable. And let's see the codes. There are 4 codes, 1, 2, 3, 4, and 1 means patient convenience, 2 means sharing of medical staff, 3 means access to equipment, and 4 means patient privacy. Now let's go back to the relationship chart for recovery first. The closeness rating between departments, here are the departments A, B, C, D, E, F. There are 6 departments, and A, B, C, D, E, F also, here are the departments. So A is the radiology, has a relationship with B that is explained with U. U means unimportant, not as such important. A with C is the same. A with C means lobby and waiting area. B means, by the way, laboratory. B means laboratory. Okay, let's move to radiology with D, that is D means examining room, or ordinary closeness. The definition is just ordinary closeness. It's okay to be close, that means. And radiology with E means surgery and recovery. So radiology with surgery and recovery is absolutely necessary for sharing what? 2 means, the meaning is for sharing of medical staff. So it is absolutely necessary for sharing of medical staff. So these 2 departments, that is radiology and surgery and recovery, have to be put or located close, or have to be side by side. And the other is radiology with F, that is F means physical therapy. So O, ordinary closeness, it's okay to be close. And the other is laboratory. And laboratory is U with C, that means lobby and waiting area. U unimportant, not as such important. Laboratory with D, that is D means examining rooms, that is O, ordinary closeness. Laboratory with E, that is E means first surgery and recovery. So laboratory I, important, and 3, access to equipment. For access to equipment, it is important to locate what? Laboratory and surgery and recovery. That means it's better to be close enough. And the other is laboratory with F. F means physical therapy, unimportant, and not such important, not important, or insignificant, we can say. And the other is lobby and waiting area with D, that is examining rooms. E means essential, especially important, and 1 is for patient convenience. So D, that is examining room and lobby and waiting area, have to be located close enough, because It is especially important because of what? One, for patient convenience. And the other is lobby and waiting area with E. E means surgery and recovery, so X undesirable, not important. 4 is patient privacy. The patient privacy should be kept. So we have to locate these two departments far away. Lobby and close area with that of surgery and recovery. And the other is lobby and close area with F, that means physical therapy. So I, important because patient convenience. And the other is examining rooms with E, surgery and recovery, ordinary closeness, and examining rooms with F, that is physical therapy. I, important for the purpose of patient convenience. This is how the relationship chart can be interpreted. The next step in the layout planning process is to develop a new block plan, a new design, or a better block plan than the one which already exists. So a block plan can be developed either by trial and error or some decision support softwares. So for the time being, we are doing with trial and error. Looking at the from two matrix, department C and D, which have 50 trips between them, department N and D 45 trips, department B and D 45 trips, the same with that of A and D, department C and F having 43 trips between them. So these departments have a much higher number of trips between them compared to the other department pairs. However, note that this is just an arbitrary decision, one that uses judgment. If the trips are close in numerical value, the operation managers can use information from the relationship chart to decide on a critical pairings of departments. By the way, now we are doing just with from two matrix. We are doing based on the frequency of movement, only just considering the frequency of movement rather than just the relationship chart. So based on that, the proposed block plan for recovery first is put like this because we have to put the largest trips, or we have to put the departments having the largest trips between them side to side. For example, C and D should be side to side. C and D should be side to side here, and A and D should be side to side because it has maximum trip, and B and D is also B and D, and C and F is also put side to side based on this data obtained from two matrix. And later, an operation manager may change this arrangement based on the relationship chart, based on the importance of the relationship, or based on the activities relation between the departments. A manager or an operation manager can modify this arrangement later. But for the time being, by considering only the trips or the frequency of contact, we just propose this arrangement. Let us see how much change will be obtained from the modified layout. So just let's put the current layout and the modified layout together in one table. And from two matrix, we get number of trips obtained from two matrix. These are the number of trips, and these are the departments. So A and D has 45, A and E 12, and F 25, and B and D 45, B and E 14, These are the number of trips with existing, or we can say the current layout. The existing layout arrangement is like this: A, B, C, D, E, F. So the distance obtained from the current block plan is just assumed to be 1 for A and D, because they are just side to side, A and E, 2, and so on. So we just multiply the frequency with the distance to get the load distance score for the existing. And when we add up, so we get 515 for the existing layout. And for the proposed layout, for the planned layout, this is just the distance obtained from the proposed block plan, just obtained from the proposed or the modified layout. So then here are the frequency. These are just the frequency number of trips obtained from two matrix. And when we multiply with this new distance, or you can say distance obtained from the rearranged or reconfigured layout, so we get this load distance score, and when we add up, we get 373. So obviously we can minimize the load distance score. So our modified layout is better than the current layout, we can say. Based on what? Based on the frequency, based on the number of trips, or just the movement. Here we just ignore the relationship, chart data. So an operation manager here can remodify this layout based on the relationship chart again. Let's move to another example. By the way, this example may be found in the previous discussion. Anyway, let's do it again. A university department office has 4 rooms, each dedicated to specific problem. The total office is 80 by 20. Each room is 20 by 20 placed along the straight line. Contact summary is from department A to B is 10, from department A to department C is 20, from department A to department D is 45, B to C is 15, B to D is 35, C to D is 20. This is just the frequency of contact. It's just the frequency of contact. And the existing layout, or the current layout, looks like this: A, B, C, and D. So the first question is draw the interdepartmental flow graph. And the second is evaluate the layout according to the material handling cost, or according to just the frequency of contact. We just consider here the distance and the frequency of contact to minimize the material handling cost. Moving to the solution, first let's draw the interdepartmental flow graph. So this is just the existing arrangement, A, B, C, and D. So let's put the contact summary on the line. A and D has a contact summary, or frequency of contact 30, A and B 10, B and C 15, C and D 20, A and C 20, and B and C has 10 contact summary. So based on this arrangement, let's calculate the costs, and let's assume that the department is located side to side has a 1 unit cost. So based on this rate, let's calculate the cost. So A and B has located side to side, so the cost is 1. So times 10, that is the frequency of contact, so the cost become 10. And AC, so AC from A to B 1 unit cost, and from B to C 1 unit, so 2 units. So we have to multiply 20 contact with 2, that is 40. AD 1 unit, 2 units, 3 units, so we have to multiply with 3, so 90. And BC is already 1 unit, so 1 times 15, 15. BD has a distance of 2 units, so we have to multiply by 2, and CD is 1, we have to multiply 20 by 1, and thus the current cost become 195. So if we get better layout which asks or which requires us to invest less than this amount, so we have to just try. Okay, let's rank from the highest contact to the lowest contact. AD has highest contact, that is 30. CD is the next highest, that's 20. AC is also 20 contact, BC 15, BD 10, and AB 10. Thus, from this contact summary, we have to put A and D side to side. We have to put those two departments, A and D, side to side, because they have the highest contact summary, that is 13. And C and D have to be also located side to side because they have the second highest contact summary. And if possible, we have to continue like this. For example, if possible, we have to locate A and C also side to side because this the highest than the given data. So I just put A and D together. I just put A and D together. So I just put like this. And the next is D and C. D and C is side to side. So I just bring C here. Then the remaining is B, right? I just put B here because the frequency of contact between A and B is just lowest, that is 10. So it's okay to be far away from A. It's okay to make A and B far away. So this is the modified layout. This is the modified layout. This one is the existing layout. So for the modified layout, let's calculate the cost. AB, let's look at AB. AB has 10, frequency of contact is 10, and 3 units cost, 1, 2, 3, so 10 times 3, 30. AC, 20 frequency, so 2 is the unit distance, so 40. AC is AC, so 2 units, so times 2, 40. AD is side to side, so 1 unit distance, 30 times 1, 30. BC is also 1 unit distance, that is so 15 times 1, 15. BD is 2 unit distance, so BD is 10 times 2, 20. CD is 1 unit, 20 times 1, so 20. The better way is ADBC because ADCB, because the cost is 155, which is lower than the previous or the existing layout. The existing layout costs 195, but this one costs 155. So the modified layout is better in terms of the frequency of contact. And as I said before, based on the other importance, an operation manager can change the modified layout even. This is all about today's discussion. So I provided you an exercise. Try to do this exercise, and if you have any questions, you can write on the comment box. This is all about for today's discussion, and we will meet with another discussion next time. And thank you for listening. Bye.